Okay, now we are going to share the screen and go to the COVID-19 challenge by Oliver. Oh my God, I love the presentation and specifically the virus itself. It was
Uh,
good and lots of PowerPoints. Oliver, thanks a lot for the time that you invested on this grand scale presentation. And thank you, man. And anytime you want to change any slide, let me know. I change the slides for you then. Okay.
yes, okay.
Or I
So
can have the remote access to my desktop from the Zoom. Then
I
you
don't
can
know
just,
how actually.
no worries. Then I do that for you then.
Okay,
Should I change
thank
the
you, thank
slide?
you.
You want to present, introduce yourself, your project, then we move on.
Yes, okay. I think I start with that.
Yeah.
So can I start now?
Yeah, please, please.
So hi, I'm Oliver. Today I will talk about uh the Canada COVID-19 data analyze and predictive model. So can you change the next
Yeah,
one?
sure,
Next
sure,
slide.
absolutely.
Thank you.
No problem.
So first, I want to talk about some basics about coronavirus, but like it seems that everyone knows a little bit about coronavirus, but I want to talk about that a little bit. So what is COVID-19? First, we introduce the symptom. So the common symptom include fever, cough, shortness of breath, and loss of smell and other things. And how it spreads? The virus is primarily spread between the people during close contact, most often through small droplets producing by coughing, sneezing, and talking. Mm, and the third is how to prevent to get the coronavirus. So the recommended measure to prevent the infection include frequent hand washing, main, maintain maintain a physical distance from each other, and cover coughing and keeping unwashed hands away from your face. So these are some basics about the coronavirus. And now we need to look at some data about the Canada coronavirus. Thank you for that.
No worries.
So this is the data for May 24th, which is yesterday. So we can see that Canada have confirmed case is 84,655 and deaths is 6,424 and recovered is 43,927 and the mortality rate is 7.6%. So this for status uh, data is the four data we need to talk about today. So first, we look at the graph. So next slide, please. Thank you. This is the graph of this three data: confirmed cases, recovered cases, and death cases during the time. So we can see the graph is actually rising in a way like a curve, but say we need to learn how this increasing. So first of all, we need to know during this coronavirus what the government actually doing. So can you skip to yes, thank you. So what the government doing is that they trying to flatten the curve. So we can see that the government make the curve flatten, but the thing is, the flattened curve have lower peak, but it takes like more time to control the whole virus, like when the virus ended. So can you next graph, please? Thank you. So when we look at the two curve, it's very similar to the graph we already learned. So is very similar to a graph. It is very similar to cosine and sine graph, right?
Right.
So next slide, please.
And just one quick question, I should say, Oliver, before you move on, what on the previous slide that I had here, what does it mean that, for example, with mitigation and without mitigation?
So without mitigation, that means the government did nothing to stop the virus spreading.
Uh-huh.
And yes, that's it.
Oh, okay, thanks. That's what it means. That means that mitigation, it's actually the government policy which
Yes,
intervenes with the speed of the COVID-19 disease. And it
yes,
means that when we have a with mitigation, it involves, I should say, the government involvement with its own healthcare policy there. Am I
yes,
right?
yes,
Oh, fantastic, fantastic. And that's a model you say that it's like the sine or cosine of one single period graphs then.
yes. So in next graph, this is the graph of negative cosine x. It's look very similar to the previous curve. So in this model, I basically use this negative cosine x model to describe the curve increasing and decreasing. So when we look at the cumulative case in Canada curve again. So next
Next slide. Yeah.
yes, please. Yes, thank
Yeah,
you.
sure.
So the way it increasing is pretty similar to the negative cosine curve. So now we know what kind of model we need to predict. We use to predict the COVID-19. So the first thing we need to predict is when is the peak. Next one, please. Yes.
Yeah, sure.
So when is the peak? So what is the peak? Peak is the highest point. So I separate the growth into three stages. At the first stages, so the growth is like the rate of increasing is getting bigger and bigger. So at the stage 1, but at stage 2, the growth is more like a linear line. So at the stage 3 is really closing to the peak. So the rate of increasing is slowing down. So we need to find out, for now, we are at what stage. So can we move to next one,
Sure.
please?
And sure, sorry, Oliver, to interrupt you. You mean that in your presentation here, the stage number 2 is the sharpest, I should say, in terms of the growth number of the person who are exposed and infected with the COVID-19, huh?
Yes.
And it means that they have the slope is the greatest one here, huh?
Yes.
Okay, nice. Then can we say that, for example, the slope of any points, you assume that your horizontal axis, it represents the time, then the slope of any points of your model represents the increase or decrease rate of the people who are infected.
Yes, that's correct.
Okay. Interesting, interesting. Very nice, man. Very nice.
Yes. So when we look at another status is active cases. So what is active cases? Active cases is that the total confirmed cases minus the recovered cases and minus the death cases. So basically the active cases is the people that still are infected and not recovered or not dead. So why this is important, because if they're ineffective, so there's a great chance to maybe they go out and get others infected. So we can, from this graph, we can see that the active cases curve is really look like the endpoint, which is May 21. Yes, May 21. The endpoint is really looks like at stage 3, because we can see that from the last part of this curve, the rate of increasing is slowing down, but it seems that it's a good sign for us. But what government do at this stage? So can we move to next one?
Yeah, sure. So you
Thank
mean
you.
that at the stage three, we are at the stage three, it represents this part of the graph at the May 21st.
Yes.
Ah, okay. Very nice, man. Very nice.
So when we approaching stage 3, what government do? That Ontario start the first stage of reopening when the curve just starting flatten slowly. So what they do cause not only higher peak but also made the peak come later. So if the like reopening immediately, maybe we're not at stage 3. Maybe the rate of increasing will like rapidly again. So we need to make a plan we need to make different models to predict that what the government do. So can we move to the next
Yeah,
one?
sure. Oliver, you mean that if the government, because we are not at the stage three, you mean
Yes.
that here, which it seems that it's gonna get flattened, go to its peak, you mean that then this model says to the government, is it the right time to do the opening or no?
We will see. I will explain that later
Ah, okay. Ah, okay. I
because I
can't
have
wait.
more
Yeah, I'm
things
so
on.
excited, man.
Yes.
Okay.
So we have this is the first situation. So the government continue lock down the cities. So from the previous curve, I put it into decimals and find the predictive curve. So if we can see the graph. The red curve represent the total confirmed. The blue curve represent the total recovered, and the green one is lower. The green one is represent the deaths, the numbers of deaths, and the red line here at the right is where's the peak, and the black line is the stage that we are. So this is the first situation. Government continue lock down the cities. That means everything is still under control. So in this predict model, I got the peak. The total confirmed will climb up to 119,000 to 120,000, and total active case will rise up to 50,000 to 55,000, and total deaths will rise up to 8,750. So this all the estimate value. They're not like that accurate, but we can know that. So what is the peak? So we can calculate the time, which is we can see that the peak is at mid-June in first situation. So then we move on to the second situation. So can you move to next one, please?
Oh, sure, Oliver, before we move on, this plot is something which you have produced it yourself or that's depicted from somewhere?
I produced by myself.
Oh, you produced it yourself.
Yes.
And okay, interesting. And those numbers which you have, the total confirmed, this is the prediction of your model itself, huh?
Yes.
Okay. What do you have the functions of those plots that how did you just got those models?
Actually, I have it, but it's really complicated, and I already deleted
Oh no, but
because
also
I
can you?
only
Oh,
need
no
the
worries.
graph.
Can you please also send it to me anytime by an email then, because I'm so interested to see them. That's so beautiful.
Okay, but it maybe take time because
Oh, no worries, no
I
worries,
deleted.
no worries at all. It's totally fine. Yeah, I go to the next slide.
Okay, so next situation is that government starts reopening, but this process, they start reopening very slowly. So at this stage, I put it in my predictive model. So the total confirmed will rise up to 140,000 to 150,000, and total active case rise up to 76,000, and total deaths rise up to 11,020. And when the peak came up is mid-July to early August. So this is just the peak. So we can see that if the government start reopening slowly, but even they do it slowly, but they still make the peak very late.
Oh.
So this is the situation 2. So then we move on to the third situation.
Yeah,
Yes, thank you.
no problem.
So at this situation, government start opening immediately. So this situation is a little bit complicated, because if they reopening immediately, the rate of change will rise immediately. So in this model, so we cannot predict that the numbers, because we don't know what happens. So in this situation, numbers are unpredictable, but I can assure that the peak is really high. If the government did that, the cost is really high.
Uh-huh. You mean that
So
if the government starts to open, let's say, we open the stores, we get to the second peak, which you have there, which shows that the number of the people who are exposed and infected drastically increases. Huh?
yes.
Ah, okay.
So
Nice.
these are the three different plans and models. So we already predict the peak. Now we move on to when all this coronavirus gone. So can we move on to next one?
Yeah,
Yes.
sure.
So now we need to compare to with other countries that already control the coronavirus, because they already control, so we can use their numbers to predict the Canada situation. So this is the graph of China. This is the graph of China active cases. So we can see that it takes 1 month to reach the peak, and it also takes 1 month from the peak to near the end. So the time of increasing and the time of decreasing are basically the same. But what China did, so can we move on to the next one?
Yeah, sure.
So basically it's Chinese, but you didn't need to understand all this. You just need to understand these two numbers. So at March 25th, China start the first stage of reopening, and at April 8th, the China is completely opened. So when we see this two time and move and like substitute into the previous graph, can we move on to the next one?
Yeah, sure.
Yes. So we can have the conclusion that China reopened after COVID-19 is fully controlled. The time between the start point and peak point is the same as the time between the peak to the lower ending point. So if Canada start reopening when the curve just got flattened, so the decreasing rate is slower than the increasing rate. So it's the time of decreasing maybe 1.5 times more than the increasing time. So can we move on to the next one?
Yeah, Oliver, so one quick question. That's a very interesting point. You mean that if the Canada, you're trying to make some inference from the model back in China that
Yes.
said it took 1 month to reach to the peak, to the highest number of the people who got
Yes.
infected. And after that, you're at the peak, it took 1 month to just flatten it, just come to almost zero at endpoint behavior, that nobody got infected. And we try to make an inference the same model to Canada. We say
Yes.
that we can expect the same number of time, the same time that that infection goes to zero, huh?
Yes.
Ah, okay.
But the truth is, Canada cannot do that because they start reopening really early, like way early than China. So now we can use that to predict that when this actual ending.
Uh-huh.
So we use the number 1.510 times. So we have two previous plans, two previous situation. So the estimate peak one is, oh, can we move on to the next one?
Yeah,
Sorry.
sure. By all means.
Oh, because I'm seeing myself PowerPoint. So the estimate peak one is mid-June. So for the estimate ending time one, so we can calculate is mid-October.
Mhm.
But for situation two, the estimate peak is mid-July to early August. For that, estimate end time is mid-December. So basically, these are the peak and time, and we also predict the numbers of the total confirmed cases, that's cases, active cases. Next one, I want to talk about something really fun. When I did this research is extension content. So the first one is actual death rate. So the current death rate is how they calculate the current death rate is that they use current deaths divided by current confirmed cases. So we can find a problem that if one patient get very sick due to the COVID-19 and he or she will die, but he or she won't die in the same day as he or she is confirmed get COVID-19. So that's a problem. So how we know the actual death rate? So can we move on to the next one? So from this graph, we can know that the average time from one patient to death is 17 days. So to evaluate the possibility of death if infected is that current death divided by 17 days ago, sorry, it's ago, not age, ago confirmed cases. So this is actual death rate. Now we can, for example, we can calculate the actual death rate for May 25th is 9.8%, but the death rate of May 25th is 7.6%. So the actual death rate is actually higher than the death rate we have like from government website. So if you use this calculating method in different regions, there may have a way bigger death rate, around like 15%, almost 20%.
Ah,
Can we move on to the next
yeah,
one?
sure. Interesting.
So the next thing I found is really interesting that, so what if the government do nothing? So now we use, so from this content, so this is from Wikipedia. So from this content, we can know that if government do nothing, so one people can infected 3.28 people. So let's say at June 25th, Canada have the first confirmed case. The total population of Canada is 27 million 590,000. So if we calculate the log base 3.28 of that number, so we can know that it is 15 between one person get COVID-19 and to have the symptom is 3 days. So we can assume that 3 days is one round because it's the easiest period to get infected. So we only need 45 days to get everyone in Canada get infected, which
Oh,
is March 10th. So that's the model that government did nothing. So that maybe quite scary. And can we move on to
Yeah,
next one?
absolutely, absolutely.
Yes. So also we wonder that at what active cases that the current health system will collapse. So first thing we need to assume that there's no suddenly increasing active cases. So we use the numbers at May 25th. So at May 25th, all beds needed is 2,051 and active cases is 34,290. So if every bed is full, the active cases around 106,500. By previous model, if government slowly starting reopening, the peak active cases is 76,000. So it seems that we're at a good situation, but that's not the truth. Okay, move on to the next one.
Absolutely.
Thank you.
No problem.
So if you look at the numbers which I marked during this period, so the real world situation is if the active cases is increasing rapidly, the beds needed is way more than our expectation. So from this graph, the highest number of beds needed is 5,374 at May 5th, but the total number of beds in Canada is 8,855. So you can see that at that day it's really close to the all beds we have. So if the active cases increasingly rapidly, we may run out of all beds in just 15 days. So this is really bad thing. So that means coronavirus is actually scary than we thought. So this is all my PowerPoint. Thank you for listening. Stay at home, stay healthy.
Oh my God, that was great, man. I just clapping for you. Oh my God, that was so impressive. Thanks a lot, Oliver. That was a wonderful presentation.
Thank you.
I like that you included all kind of details, and I like the model which you prepared for those three stages that you mentioned and those graphs which you plotted, and it was wonderful. Thanks a lot. And you aced the challenge, COVID-19 challenge of the class, then man, congratulations.
Thank you.
Thank you. Let me stop the sharing, and then any questions, guys, for Oliver? Then Oliver, one quick question for you before we end of the class.
Yes.
What time is gonna be think that based on your model is the best time that the government opens the whole city?
So in my model, so I think the best time is open that the when the curve is really close to ending. So at the first plan, so the peak is mid-June. So the best situation that government can start reopening at early July.
Oh.
It's the best thing to do because that did not make like more cases.
Oh, okay. Okay, that's very interesting. I have a very good insight now. What time the quarantine is gonna be over then? Thanks a lot, Oliver. I really enjoyed your presentation. It was wonderful. Thanks a lot, man. You aced the COVID-19 challenge in the class then. Thanks. Thanks. Then guys, we have